Amplify Science, Matter and Energy in Ecosystems, Chapter 2, Lesson 2.5, Investigating Econauts Claims, Review Video for Green Group. So based on your Lesson 2.4 test results, you will be placed in a group, and this is about the Green Group. So you know you're in the Green Group when your screen looks like mine, and it has a big banner across it says Green Group. So Green Group warm-up has to do with hydrothermal vents, so the ecosystem you're given. Take a look at it. There's a claim, and you are providing a possible answer to that claim. The teacher will then explain to you, as I just have, that you are broken up into 3 different groups, the class, based on your results, a purple group, blue group, and green group. And again, this is the Green Group review. We move over to the simulation. I'm going to need to switch this to Green Group. Okay, so Green Group, again, you have an article on the deep sea vent, and it talks about how deep sea vent is different than the other ecosystems we've seen because it operates without sunlight. And how does that happen? Where does the energy come from? You're introduced to this idea of chemosynthesis, that there's bacteria that can do this chemosynthesis using hydrogen sulfur as energy and grabbing the carbon dioxide out of water. It introduced you to tube worms and shrimp and octopuses that live near the sea vent. So pay close attention to those organisms and build a food chain, a food web in your head. In other words, what is eating what is eating what? How is the energy storage molecule moving from the chemosynthetic bacteria, which act as the producers, to the tube worms and the shrimp, and then on to the octopus through the ecosystem. In the second screen, you're going to run the simulation. So I'm going to open up the simulation, and there are specific instructions for you to do. So the part 1, you're going to run this. So now that the simulation is loaded, you are going to go up first thing and turn off the sunlight to none. And then you're going to run your ecosystem. I like to run it a little bit sped up just to see what's going to happen. Okay? And you're going to observe what happens when there is no sunlight. And what you should start to see is the energy storage molecules are no longer produced by the producers. And so they start to decline or go down in all of the organisms after that, to the point where there are no more energy storage molecules in the ecosystem. There's no energy for the producer to produce energy storage molecules, in this case, sunlight. And you're going to want to respond in the square to explain that. Then you're going to represent a deep sea vent in the sim. How could you do that? Same thing. You're running it without sunlight. So you have to think, how could the deep sea vent ecosystem survive without sunlight? And what you need to know is the energy, where that sun should be. You have to, in your mind, imagine hydrogen sulfide chemical providing the energy. Instead of air being in the area at the top, the abiotic matter, it's water. So the carbon dioxide that's dissolved in water is what's available to your new producers, which are the chemosynthetic bacteria. They are producing energy storage molecules that would go on to the tube worms and the shrimp, and then to the octopi or octopuses. Dead organisms are going to fall to the bottom of the sea floor. Bacteria can function as decomposers there. And so when you fill in the table, so features in the sim ecosystem that are only in the sim ecosystem, in this case, your producers would be plants. You have sunlight. Those things that are only in the deep sea vent, you now have hydrogen sulfide and dissolved carbon dioxide in water. I guess in the features in the sim ecosystem, you could also put air. And you also have these chemosynthetic bacteria. And hydrogen sulfide is the energy source. Features in both, they all have producers, consumers, decomposers. They all have some form of energy storage molecules being passed through them. They all have some source of energy. So in the bottom, in question 2, how would you change the sim to represent an ecosystem that depends on chemosynthesis? I'm going to scroll down to the numbers and talk about where you would do that. So in area 1, it would be water instead of air. In step 2, you would have hydrogen sulfide chemicals instead of sunlight. Your producers in 3 would be the chemosynthetic bacteria. Your primary consumers are the tube worms and the vent shrimp. Secondary consumer would be the octopuses that I mentioned in the article. Decomposers would be bacteria. The dead matter in the bottom would be the seafloor. And that would be some ways that you could explain that. Moving on to 3, you have you claim populations in the deep sea vent ecosystem can get energy storage molecules without sunlight. And somehow you need to explain that you understand that, yes, they can. It's using the hydrogen sulfide energy by the chemosynthetic bacteria to produce energy storage molecules to pass through the ecosystem through the tube worms and shrimp and other decomposers. Hand that in. In step 3, word relationship, you're having a discussion, going over your answers with others, using these terms. Okay? And so make sure that you understand the meanings of these terms. If you don't understand any of the meanings of these, you want to review that with your peers or ask your teacher. For homework, step 1, go back and respond to the Econauts claim in step 2. That was the final screen. If you need to improve your answer based on what you learned during the discussion. In Glacier Mice article in the second screen in step 4, I've highlighted answers to the questions that you see on the right. So how are they complete ecosystems? One glacier mouse can be the home of hundreds of microscopic organisms. After a while, each glacier mouse becomes a complete ecosystem. The moss is the producer, and then the tiny microorganisms are the consumers and decomposers. What does it mean to define the boundaries of a system? Well, I've highlighted here, when scientists study ecosystems, they must define the boundaries of what they're studying. They have to say where in one ecosystem stops and another begins. And in this case, the clump of moss is the whole ecosystem. It's separate from the surroundings. It can move around on its own through wind and water and erosion and things. So when they study just that ecosystem, they say, look, the moss, the edges of the moss separate it from the rest of the ecosystem. So that's the boundary. And then what is one way a surrounding ecosystem can affect the glacier mouse? Well, they've listed a couple here. For example, energy enters the ecosystem when the sunlight shines on it. So is it in the sun? Is it in the shade? Glacier mouse ecosystems also exist as part of the larger ecosystem of glaciers where they're located. An animal can climb onto the moss and become part of the glacier mouse ecosystem. It can fall off and become part of the greater ecosystem around it. Or when it's blown to new areas, animals can enter and exit the glacier mouse. And then in step 5, self-assessment. So this is you self-reflecting on how you feel about how comfortable you are with what you know. So there's no right or wrong answers here. It's just a way to self-check. And that is the green group review for lesson 2.5.